All right, this is going to be the exponential form and rules of exponents homework help video. I'm going to go a little bit more in depth on this one because of the delayed start today. We also had a lot of absences, so I'll try to get a little bit more in depth, reteach some of these concepts so that we are where we need to be, especially for Monday's test. Starting with number one. Write each expression in exponential form. So in exponential form, I don't want any radicals in my final answer. To convert this to exponential form, it follows the same pattern each time. Take the radicand, put it in a set of parentheses so that it's all stuck together, and raise it to the power of whatever exponent is out here divided by the index. So the index is 5, so that goes into the bottom of this fraction, and I'm raising it to the power of 2, so that goes up there. It's just that same rearrangement every single time. Parentheses are important here so that it doesn't look like that exponent is being applied to only the b. Same thing with number 2, 6k to the power of, the 3 goes on top, well, what goes on bottom? Well, the index of this radical should go on the bottom. I don't see a number here, but it is a square root problem. So the index, although we don't write it, is always a 2. So this should be 6k to the power of 3 over 2. Number 3, this one involves yet another property to get to the final answer. It's written in a fraction with a 1 on the top. That is automatically making me think about my negative exponents property. So if I want, let me first rewrite that cubed root of 7 as 7 to the 1/3. But if I want to write this without the fraction, I can just use the negative exponent property and write this as 7 to the power of negative 1/3. So these are equivalent. A negative, to get rid of that negative, we would keep everything the same and put it in the denominator with a 1 on top, and then we can go the other direction if we want to. So that's going to be our final answer for that one. Looking at number 4, pretty similar. I can rewrite this as 1 over 2 to the power of 5 over 4. Which then becomes 2 to the power of negative 5 over 4, so I can get it out of the denominator. Final answer for that one. All right. Now we're going the other direction. In these problems here, rewrite each expression in radical form. For number 5, the base becomes the radicand. The bottom of the fraction becomes the index. And then we can put this all raised to the power of 4 at the top of that fraction. If we wanted to, we could put that 4 inside the radicand, but make sure it's being applied to both the 7 and the p. It's not just p to the 4th, it's 7p to the 4th. All right, I think we're good with these ones. Number 7 is the cubed root of a. Now, 9 through 14, since we have all numbers, it's very likely we're going to be able to simplify this down to a single number. We'll start with number 9, 64 to the power of 1/6. I say convert to radical form and then simplify, so we need to write this as the 6th root of 64. Now, what number raised to the power of 6 equals 64? That number is 2. One way to check this is to do 64 to the power of 1/6 in our calculators and make sure that we get a 2. Or we could double check by doing 2 to the power of 6 and making sure that that comes out to 64. Both work out. Number 10 here. First thing I want to do when I'm converting into radical form is get rid of the negative. Let's make this 1 over 8 to the 1/3. And then a raising something to the power of 1/3 is the same as taking a cubed root. The cubed root of 8 is 2, so this just equals 1/2. 4 to the 3/2, that's the same as the square root of 4 cubed. The square root of 4 is 2, so 2 cubed, which equals 8. All right, if I wanted to do that in my calculator, I can, but the directions specifically say convert to radical form. Let's just take a look at, make sure that we know how to plug that in. 4 to the 3/2. So I do 4, this caret button, and then in these calculators, if I keep typing, it all stays up in the exponent position. Otherwise, I might want to put a set of parentheses around that to make sure that it's all in the exponent. And we get the answer 8. Let's see, number 14 looks like a good one. 10,000 to the 5/4. Well, let's convert that to radical form first. So that's the 4th root of 10,000, all raised to the power of 5. Well, the 4th root of 10,000, what number times itself 4 times equals 10,000? That's just 10. And then 10 to the 5th, well, that's a 1 with 5 zeros, or 100,000. All right, solving equations where we've got a rational exponent. We're going to use something called the power to a power property to get rid of our rational exponent. But before we can do that, in problem number 15, we got to get everything moved away from this rational exponent that we can. And so we can divide both sides by -5. That's going to help us isolate that exponent there. And so now I've got x minus 18 to the 4/3 equals 256. All right, and so now here's where we use the power to a power rule. If I raise both sides to the same power, I'm allowed to do that. I can do it in a way that gets rid of the exponent over here. And that's because if I raise powers to other powers, I end up multiplying those powers. So I'm going to raise these both to the power of 3/4. 4/3 times 3/4 equals 12 over 12, or 1. So those cancel out. Always use the reciprocal right there. I'm going to get 8 minus 18 equals 256 to the 3/4. Because it's good practice, let's not use our calculators on this. This one won't be too hard to get on our own. This is equal to the 4th root of 256, all raised to the 3rd power. Well, the 4th root of 256, I can look in my x to the 4th column for 256. But the answer is 4. So I'm going to write that over here. X minus 18 is equal to 4 to the 3rd. And now we're just finishing out the problem using basic algebra. Add 18 to both sides. X equals 82. Let's check and make sure we're doing this right. That was number 15. 82 and -46. That's for 15. Okay. So I think I'm going to let you ignore this for this unit. Technically, the 4th root of 256, because that's an even root, should be a positive and a negative 4. So we should get x minus 18 equals negative 4 to the third. And now with the 3 being odd, this becomes negative 64. We add 18 to both sides, and we get x equals negative 64 plus 18, negative 46. And so that was the two answers in the answer key. But we're going to say for the rest of this unit, we're not going to worry about the positive and the negative root of even answer of even roots. We'll just focus on the positive. And so we'll just say x equals 82 for this one. And we'll save that for another day, making sure we know how to find both answers. Looking for a difficult one. Number 19, I guess looks kind of challenging. I want to add 9 to both sides. And you get 4 to the n plus 19. 3 halves equals, what is that, 2048. Divide both sides by 4. We get n plus 19 to the 3 halves equals 2048 divided by 4 equals 512. All right, what we can do to get rid of our rational exponent here is raise both sides to the power of 2/3. This is going to make n plus 19 on the side after those cancel equals the third root of 512, all of that squared. All right, the third root of 512, I'm just going to figure that out by doing 5 to the power, or 512 to the power of 1/3 in my calculator. So 170 and 2/3. What do I get when I square that? 512. Let me just try 512 to the power of 2/3. 512. 64. So that's 512 to the 1/3. Oh, I was forgetting to do parentheses in my calculator. But okay, the cubed root of 512 is 8. Eight squared is 64, so now we've got n plus 19 equals 64. Subtract 19 from both sides, we get n equals 64 minus 19, 45. And if you've got a calculator, you don't need to go to the radical form here. You can just do 512 to the power of 2/3. I was trying that in my calculator. I forgot to put parentheses around the 2/3, and so I was getting a strange answer. I was getting 512 to the power of 2, then divided by 3. It's not the same. Let's see. Number 21, I could rearrange this to be 4 times 4 times r to the third times r to the negative 3. When I multiply exponents to the same base, I add their exponents. So the r to the third plus r to the negative 3 is just r to the 0, which we know is just 1. So this is just 16. Here, I can just multiply the coefficients, and then add the exponents. A power raised to a power is going to, you end up multiplying the powers, and this 3 needs to get distributed to both of those 4. So this is going to be x to the 12th, y to the 12th. Similar thing happening here, number 24. This becomes 4x to the 0, y to the 1, which is just 4y. Let me double check that, 24. Oh, yeah, no, I made a mistake here. We've got an exponent raised to an exponent, so I don't add those, I multiply them. So this needs to be 4x to the power of, well, actually it needs to be 4 to the power of negative 1/3, x to the power of negative 9, y to the power of negative 12. And then this all here equals 1 over 4 to the 3rd times 1 over x to the 9th times 1 over y to the 12th. And then 4 to the 3rd is just 64. All these fractions can combine again to be 1 over 64 x to the 9th, y to the 12th. Yeah. Let's see. 26 is, well, let's just do 25 to start. We've got the fraction of 2 exponents with the same base, so we subtract their exponents, and I can just keep that 3/4 in front. So 3/4 times u to the 4 minus 2, which equals just 3/4 u. Let me write that. Just a straight up and down fraction, u squared. All right, we'll do 28 as our last one. Across the top, we can multiply the coefficients, add the exponents. This is going to become 4x to the 6th. This is all raised to the power of 0, which is equal to 1. Anything to the power of 0 is 1. So this equals 4x to the 6th for 28, 4x to the 6th. Yep. All right. Well, hopefully that was helpful. Help you finish up your homework. And get you started on potentially studying for our unit test in a week. All right. Have a great rest of your day.